All right, so we're going to be talking about another kind of section. We discussed circles, okay? And see, notice how that plane, that orange little like paper, it's kind of like if that's the coordinate plane, we slice the cone, and that is the circle we create. Today we're going to focus on the parabola. So the parabola, notice how the orange paper, the slicer, kind of slices the cone at an angle, and it creates a parabola. Okay, and just like a parabola with a quadratic equation, very, very, very similar. But there's a couple of key differences here that we're going to point out together. So today we're going to be focusing on parabolas. So let's go back here. Okay, so let's say I told you that the vertex of this parabola was right here. This is at 0, 0, so that's 1, 2, 1, 2. So if I said the vertex was a 2, 2, how would you write this in vertex form? Well, you'd say, Mr. Schwand, I'm pretty sure we write y equals x minus 2, because whatever the x part of the vertex is at 2, 2, we do the opposite of what's with x, and then we just write y as it is. And so this is what a parabola would look like as a quadratic equation. Now, when we're dealing with conic section parabolas, pretty much everything's the same except for a. Okay? Now remember, a is usually a number in front, and it could be a 3, this could be a 1/3, right? And it tells us if the parabola is going to be fat or skinny, or if it's going to be vertically stretched or vertically compressed. And essentially we're going to have the same thing here, except there's another piece of this parabola we need to add. It's something called the focus. So remember when I did those demonstrations of different types of parabolas in real life with solar panels and satellite dishes, there's always a focus point inside the parabola. Okay, so the focus tells me whether the parabola is going to be a little bit wider or it's going to be a little bit fatter. Okay, so it's going to tell me it's going to be a little wider, a little bit fatter. But here's how we determine that. We count the distance to the focus. So 1, 2, 3. So the distance to the focus, which we'll call P equals 3. Okay? And the number that goes in front where A usually is, okay, we're going to write this. A equals 1 over 4P. Okay? So where A usually goes, we're going to write 1 over 4P. Okay? So if the focus is 3 spaces away from the vertex, that means I'm going to have 1/4, and then down with the 4 we put the 3. So it's not 1/4 times 3. On the bottom it goes 1 over 4 times 3, which is 1/12. So 1/12 x minus 2 squared plus 2. Okay? Now, I know what you're thinking. Well, Mr. Schwant, why is it different than when we did the quadratic modeling? So I wanted to show you this way to tell you that it's very, very, very similar to what you're used to, but instead of using A, they use this 1 over 4P for the focus. Okay? Now, the 1/12, what that tells me, again, that still tells me how fat or skinny the graph is going to be. Okay? So if it's 1/12, that means it's going to be obviously a lot fatter, because that still applies. If it's less than 1 but bigger than 0, it's going to be fatter than usual. And again, the closer it is to 1, the skinnier it's going to be. And if it's over 1, that means it's going to be a lot skinnier. Okay? So that would be the equation if we were to have the vertex there. Okay? Another way you might see this is written like this. The only thing that's going to change, instead of writing plus 2 on the back, they could write this instead. So remember with the circle, if the center moved, remember we did the opposite of x and with y, we could do the same thing here. Okay, so you're going to see the equation in both different ways. Okay, so important things to notice. Just like before, we write it in vertex form. One of the big changes is that we have to find the distance from the vertex to the focus, which is p, and then we multiply 4 times whatever p is to get the number that's in front, which is usually a, but remember it's 1 over 4p. Okay, let's do another example here to see if we got a hold of this. Let me change the background here. Sorry about that. All right, here we go. So let's say I had a parabola facing like this. Let's say it was here. So -3, 2 is where my vertex is. And it was facing like this. And I told you that the focus was right here at, this is -3, 3, -3. Okay, so first thing I'm going to do is, using my vertex, which of course we know this is the vertex. All right, so it's going to be y equals x plus 3 squared, and then we have plus 2. Okay, now normally we'd have a in front, but remember we discovered that a is really 1 over 4p. All right, and p is the distance from the vertex to the focus, so 1, 2, 3, 4, 5 units. So p equals 5. And then that means 1 over 4 times 5, which is 1/20th. Okay, so 1/20th. So A is 1/20th, or again, the focus stretch or compression is going to make it 1/20th x plus 3 squared plus 2. Now, something that I won't tell you is it's actually going down. So notice how I went down 5 units, so it's going to be -5. So if I plug in -5 there, that's actually going to make the whole thing negative. So it's going to be -1 over 20. Okay? And again, the way you might see it is that they might move this 2 to the other side, meaning it might be y minus 2 equals -1/20th x plus 3 squared. Okay, so this is for the most kind of common way we see parabolas and the way they're used. I'm going to do a second video where parabolas, rather than facing up and down, will be facing right and left. Now, there's really nothing fancy to focus on, except for just recognizing where the focus and the vertex is. For example, let me give you one more of these, and then we'll be done. Let's say I told you, all I tell you is the vertex is at 2, 4, and the focus of this parabola is at, let's make it 9, 4. Oh, excuse me, that's wrong. Let me try 2, 9. There we go. So that's all I'm going to tell you for this. So hopefully you're like, okay, well, I guess we can make a graph of this on my paper. Okay. In fact, well, I'll make it a little bit bigger here. Okay. So if my vertex is at 2, 4, so 2, 4. And then my focus is at 2, 9. 5, 6, 7, 8, 9. Okay. This tells me that the parabola is going to be opening up, because the parabola will always open up towards the focus. Okay. And using my vertex, we're going to write the usual equation. So y equals x minus 2 squared plus 4. Okay. Now we have to determine what a is, but of course we know a really equals 1 over 4p. And p, of course, is the distance from the vertex to the focus. So I'm going to go up 1, 2, 3, 4, 5. So p equals 5, positive 5. So a is equal to 1 over 4 times 5, which is 1/20th. So it's going to be y equals 1/20th x minus 2 squared plus 4. And as I said before, we could move this over here. and it could be y plus 4 equals 1/20th x minus 2 squared. Okay, so again, just use the information you have to graph the vertex and the focus, and then remember the key things that have changed. And we have a focus point now rather than just a vertex, and that helps us determine how fat or skinny it is, because that's the new A, and we can shift things around, move things around. So there we go, and hope this gets us on the right track.